So this is Edexcel S2, January 10, question 4, and this is another question on this paper about continuous random variables. So in this question we've got the continuous random variable x, and we're told that it has a probability density function, little f of x, given by this. So we're dealing with two supports here, well three because you've got the otherwise, and we're asked to show that k is equal to 1/9. So again, there's a bit of work that's required. So the point here is that the integral over all values of x of f of x must equal 1. So we've got three regions to deal with here. So we're going to be integrating from 0 to 3. K, that can come out because it's a multiplicative constant. X squared minus 2x plus 2. We're then integrating, and again 3k can come out between 3 and 4 of 1 dx, and all of that should equal 1. So calculating this now gives me k x cubed on 3 minus x squared plus 2x, and that's going to be between 0 and 3, plus 3k of x between 3 and 4, and that should all equal 1. Okay, so if we now calculate these, this is going to work out and give me k times by 9 minus 9 plus 6 plus 3k equals 1. So we can see that this is going to give me 9k equals 1, so k equals 1/9. Okay, and then the mark allocation here is as follows. So you get a method mark for recognizing that you've got two aspects, two supports that you need to integrate and add together. You then get an accuracy mark for getting that correct. You get a method mark for doing the correct integration, and it is dependent on the first method mark. So if you haven't started the question correctly, you just get nothing for this question. And then of course we get an accuracy mark for getting the answer all the way down to 1/9. So now we know that k is 1/9, we're now asked to find the cumulative distribution function. Okay, so we can now change this so it's 1/9, we can change this so it's 1/3. So the cumulative distribution. Now there's a variety of ways of doing this one. The way that most students like is to use dummy variables to do this. So again, I'll show you two ways. So we could go from 0 to 3. So we're going to integrate on the region 0 to 3. We're going to integrate, and the idea is I'm integrating from my lowest value to some given value. So again, what I need to do is actually change my variable to t. So I'm dealing with some idea of a dummy variable. So this is now going to give me 1/9 of t cubed on 3 minus t squared plus 2t between 0 and x. So if I substitute this in, it's going to give me 1/9 of x cubed on 3 minus x squared plus 2x. Okay, so that is just for the region between 0 and 3. So now I need to consider, well, what about between 3 and 4? Because that's going to be something slightly different. So again, between 3 and 4, this time I'm going to be integrating a third with respect to a variable, but we're going to be going from 3 to x this time. So when I do this integration, it's going to give me a third of t between 3 and x. So substituting this in is going to give me x on 3 minus 1 over 3, if I substitute everything in. Okay, and the reason it's minus 1 over 3, let's just consider this, it gives me x over 3 minus 1. But I do need to consider the fact that there is 2/3 from the previous case. If I substitute 3 into this situation here, okay, that's going to give me 1/9 times by 9 minus 9 plus 6, which is 2/3. So I do need to consider that. Okay, there's a slightly nicer way potentially of dealing with these where you use limits instead. So once we've done that, we're now in a position where we can actually express our entire function. So here we go, capital F of x will equal, so it's going to be 4 areas. 0 if x is less than or equal to 0. It's going to equal 1/9 of x cubed on 3 minus x squared plus 2x if I'm between 0 and 3 is going to equal x on 3 minus 1/3 if I'm between 3 and 4, and it's going to be 1 if x is greater than 4. Okay, so I'm just going to change pen colour and just show you a slightly different way of doing this. Okay, so the other way is, instead of having to worry about this 2/3, is to consider doing this using boundary conditions instead. So I know that f of 4 must equal 1. Okay, I know that because it's the highest value on my stanchion, on my support. So here we go. This time I'm going to integrate, but I'm not going to use limits, and I don't even need dummy variable here. Okay, so if I integrate this, it's going to give me x on 3 plus a constant. Okay, and that's going to give me f of x. And I know that f of 4 is 4/3 plus c, and that must equal 1. So that tells me that c must be minus 1/3. So that's another way of getting that value out. Again, it's quite common that people forget that there. Okay, so you got 6 marks for this. So you're going to get 2 marks for integrating correctly the first aspect. Okay, you then get 2 marks for integrating the second aspect, M1A1. You then get a B1 for correctly filling in f of x. So if it's all completely correct, you get B2. For every aspect you miss, and it's this bit that people mainly miss, you will lose a B mark from that. Okay? So we're then asked to find the mean of x. So the mean of x is the expectation, and that is the integral over all values of x fx. Okay, and of course we know that k is 1/9, so we can change that in the question. So we're left with integrating integrating 1/9 from 0 to 3 of x times by x squared minus 2x plus 2 plus the integral from 3 to 4 of x over 3 dx, and calculating that through. So if I do that integration, it's going to give me 1/9 x to the 4 on 4 minus 2x cubed on 3 plus x squared evaluated between 0 and 3 plus x squared on 6 between 3 and 4. Okay, and if you evaluate all of that, it will give you 29 on 12. Okay, so you only get 3 marks. So you get 1 mark for using the formula correctly, you get an accuracy mark for integrating correctly, and then another accuracy mark for getting the answer correct at the very, very, very end. We're then asked to show that the median lies between 2.6 and 2.7. So I know that big F of m equals 0.5 is a definition of the median. Okay, now we've worked out big F of x. Okay, and I'm dealing only in the interval between 2.6 and 2.3. So just to remind you, between those two regions, f of x turned out to be 1 over 27 after I tidied it up. It was 1 over 27 x cubed minus 3x squared plus 6x. Okay, that was for the region between 0 and 3. And that's the only region I'm going to be considering here. Now, it's a show that question. Now, you could set this to equal 0.5 and solve it if you wanted, but you can appreciate that that's going to be a little bit difficult. So, because it's a show that, we can actually use the fact that if I put 2.6 in, and I put 2.7 in, something interesting happens. So if I put 2.6 into this equation, I actually get 0.48. Okay? If I put 2.7 into this equation, I get 0.52. So what I know is, because big F of x is continuous, and I know that f of 2.6 is less than f of m, which is less than f of 2.7, then m must lie between 2.7 and 2.6. Okay, you're using a little bit of core 4 there, I think, to be able to do that. Core 3, sorry, something called the intermediate value theorem to do that. So that would be sufficient. Okay, so to get the marks, you get a method mark for recognizing that f of m equals 0.5. You get a method mark and an accuracy mark for then calculating the two values, and you get a dependent accuracy mark for some statement about the accuracy of the median being between 2.6 and 2.7.